Hi everyone, today I'm going to talk about a super cool topic, how sulfur gases from ancient Martian volcanoes may have changed Mars' early atmosphere and warmed the planet enough for liquid water to exist. Since liquid water is a key requirement for life, this research helps us figure out whether Mars may have once been able to support life. Today, Mars is a cool, dry desert with an average temperature about -8 degrees Fahrenheit. But billions of years ago, Mars has active volcanoes that once released large amounts of sulfur gases into the atmosphere. On Earth, sulfur gases can act as greenhouse gases or form aerosols that influence climate. So scientists wondered, could these volcanic gases have warmed early Mars enough for liquid water and possibly simple life to exist? For many years, scientists believed that ancient Martian volcanoes mainly released sulfur dioxide, a gas that Earth's volcanoes commonly emit. But new research from the University of Texas at Austin shows something quite different. Their study found that 3 to 4 billion years ago, Mars volcanoes likely emitted reduced sulfur gases, such as hydrogen sulfide, the one that smells like rotten eggs, disulfur, a very reactive sulfur molecule, and possibly sulfur hexafluoride, one of the strongest greenhouse gases known today. These reduced sulfur compounds are highly reactive. When released into the early Martian atmosphere, they could form a sulfur-rich haze. This haze, combined with greenhouse gases like sulfur hexafluoride, could trap heat and warm the planet. According to the researchers' simulations, this warming could have helped liquid water to stay on the surface, even if temporarily. For example, sulfur dioxide can react with chemicals like hydroxyl radicals and oxygen in the atmosphere through these steps. Sulfur dioxide reacts with hydroxyl radicals to form hydrosulfide. Then hydrosulfide react with oxygen to produce sulfur trioxide. Finally, sulfur trioxide combines with water to form sulfuric acid. The sulfuric acid that form aerosols that scatters light and help warm the planet. Similarly, hydrogen sulfide can also be broken down in the atmosphere like this. Hydrogen sulfide reacts with hydroxyl radicals to form HS radicals and water. Then the HS radicals react with oxygen to form sulfur monoxide. So these sulfur gases help create conditions warm enough for liquid water, which is important for life. Importantly, the haze itself does not turn into liquid water. Instead, it acts like a warm blanket around the planet. By trapping more heat, the haze raises surface temperatures enough for ice to melt or water to remain liquid. So the haze helps create the right temperature conditions needed for liquid water to exist. Liquid water is essential because it is one of the basic requirements for life as we know it. The study's predictions were supported by NASA's Curiosity rover's findings, which gives strong evidence that reduced sulfur gases help warm early Mars. Impact. These findings suggest that early Mars may have not only the temperature and chemical conditions for liquid water, and possibly even for life. Understanding how sulfur affected Mars' early climate also helps scientists learn how atmosphere evolved on other planets, including Earth. As a next step, scientists should continue studying how sulfur chemistry connects to climate, and keep exploring Mars for minerals and atmospheric signatures that indicate past chemical reactions. Thank you for listening.